Hello everyone, welcome. Today I'm going to introduce you to tuples. It is similar to list, and it is the next data structure that I want to introduce. The first one is list, second one is tuples that I want to introduce you today. The big difference between lists and tuples is that lists are mutable, changeable. Tuples are not mutable, immutable, not changeable. What changes the list? For example, insert changes. You can put something inside, you can pop something out, you can append to it, and so on, right? And you can't do that for tuple. Okay, so fine. And the special characteristic of tuple is that the boundaries notation. Here you have a square bracket, which is quintessential symbol for list. You will have left parenthesis like this, the usual, what we call it as left paren. Sometimes we call it as left paren, right? Left parenthesis like this. Okay, this is called tuple tuple generator. Actually, we don't call it as it is comprehending it, but it will not print out immediately like what happens with the list. Okay, so let me go back to this definition here. So it is a list right now, and if I do that, of course I'll get all those things. Okay, and I also want to tell you that this function, special function here, range, the list makes it as an iterator inside its list. That's why it was able to calculate these things and make it immediately available. But this is not an iterator. It is iterable, it has a potential, but it is not an iterator. Okay, when you define it as a separate function, like so I just, if I say range, because it is going to create a tuple, that's the point. Okay, so range, if you say type of range, it simply says range. Okay, so tuple container is characterized by this this kind of special boundary parenthesis, and the famous tuple is that range function 1, 2, range function, which is a start, end, and then skipping point. So optionally you can use that as a skipping point. So this creates a sequence of iterable items. Range creates a sequence of iterable items. Okay, but it is not an iterator. Okay, and a tuple is also called because of the tuple is also called iterable. I'll tell you why it is iterable: because it has a potential to iterate, but it will not iterate unless you make it iterable. Okay, unless you make it as an iterator. Okay, it is an iterable, but it is not an iterator. Because it has the potential to iterate. That's why it's called iterable, but not an iterator. In order to make it into an iterator, then you have to use an iter function on it and then call it. Then it will become iterable. Then it will act like output generator. Okay, that's what I'm going to say. Now, so let's just do this one. That this is if I do this one, this is if I ask for range, it will say range. But if I do this is list comprehension, it will print immediately. I don't have to store it. But if I do this one, it simply says generator. Okay, so think about it again. I'm going to say this one: range function creates a tuple, and tuple has a potential to be an iterator, so it is called iterable, but it's not an iterator. But it can be converted into an iterator with the iter function. We'll come to that. But before that, it is said that function is this function, this tuple created by this is a generator, because it used the potential function, range function, to generate a collection of items. But the tuple right now is a generated function. Okay, generated right now, but it cannot be print out like what the list did. List is very flexible it's in its operations, but tuple is a very careful, very purposeful function that is used for many purposes. Okay, for example, very secured operations. Tuples are the things that you have to use, because it cannot be it cannot be changed once you define the list of item inside. So how do we get the values from the generator? There is a function, special function called next. So you can use the next function here. That's what we are doing here. So I created a iter, okay, and then you can use, it is called, this is in remember, I'm going to talk a few things here. I talked to you about range function, okay, which is an iterable but not an iterator. But within the tuple, it creates the elements inside, and becomes a generator. That means a generator is a class of functions which is has the potential to release one at a time. Okay, that's what it is, and hence it needs a function called next, because it can release one at a time. Okay, so I use the function next on this a iter, then I keep on using in order to get every item, and it will keep giving every item until it finds the end of it. Okay, so so in this case, remember, in this list of items, values that are generated inside are 1, 4, 7, 10, 13, 16, 19. Next one is 23. So 19 plus 3, 20, 22. So it is outside the range of the end point. So it will not. It will raise an error called stop iteration, because you are doing too much iterations. It is over. I don't have any more to give you. That's what it says. Okay. So so we have to know how to handle this kind of situation. That's a separate issue. We'll talk about it. But I want to tell you that I want to tell you a special function about what is called the range function. Also, I want to tell you the comprehensions in tuples are functions that are going to be coming out as generator functions. Okay, so here I can use iter. How do I know that I can use it? So I created an empty tuple here, and then I asked for that. What are the possible functions that are available for that? This is the function. This is the function you have to use in order to understand that. So I said A is an empty tuple, and then I asked for, okay, what are the functions I can use? Method, special functions. These are called special functions, called dunder function, double under format, double under. So these are called dunder functions, and also the methods. The object methods are count and index. These are the only two object methods available here for a tuple, but there are many other dunder functions are available. And iter is one of the dunder functions, okay, which means you can apply that as a function for the as a function, not as an object method. Object method means you have to put dot that function, that method, right? But this is a function. That's what double under is about. That's the difference between double under and the method. Okay. So so I can make it as an iter, and then it becomes iterator. Okay, I can use the function iter, then it becomes iterator. If you want to convert a tuple as an iterator, you can do that. Okay, so the other thing you want to see is, can I convert a tuple into a list? Oh, once you know one data structure, there are few other data structures. You really want to see how you can convert from one data structure to another data structure. So the function list function will change the tuple into a list. So for example, range, I put all those in range 1, 20, 3. Then it creates 1, 4, 7, 10, 13, 16, 19. But that is not it is not iterator, and it is not going to generate the values immediately and so on of the full values. Then if you apply list, then it converts it into a it converts this into an iterator and creates the values, the full collection of values, and prints it out for us as a list. Okay, so let's do this in a little bit more complex function. So little bit more, it's not really complex, but here is the function 3x plus 2 for x in the range, the same range, right? And then I called it as comprehended tuple. So again, this is if I say ask for tuple, it's a comprehended tuple, but if I ask for the type of it, it's going to say generator. You remember that, okay? And then so I have to use the next function. So I do that here, and did it. But when it goes beyond that 19, it's not going to generate any value. It's going to say this is the 19 is over up to this. Okay, now next value comes, ask for the next value. No, stop iterating. I don't have any more. That's what it says here. So I just want to give you this the importance of tuple and its special functions, and we did some examples. Also take a look at this one. Okay, you can do with the comprehended tuple, you can use for to pull out the items. Again, one at a time you can do that. You are doing it here. Okay, that's another way of pulling out the values from the tuple comprehensions. By the way, I introduced this time generator functions when the same comprehensions used in the list are used in tuple containers, it becomes a generator. Okay, why do I care about generators? This is because in many situations we need an instance of a function evaluated, not the whole list of function values. In those situations, generators are ideal, okay, giving us the instance specific values. Okay, so the question could be, why not generate a list and then convert it into a tuple and pick a specific indexed item? Okay, is it possible? Of course, yes. So that's where the conversions will help, right? So here is an example. I go back to the same. I use that list function here. Now it becomes list of comprehended tuple, and the moment you call for it, it will going to give you as a list, because it's a list of even though it's a comprehended tuple. Now I convert it into list. It is coming back as a very straightforward. The whole collection is coming to me as one set, one collection of numbers. Okay. Of course, once you convert into it, I can do some functions on it. Sort, all those things. But what I want reverse as well as reverse also. What I want to introduce, the extend function, which I didn't talk. Extend method for lists, which I didn't speak with you earlier. So I'm going to introduce that. So let's consider the berries, 8 items berries as berries, which is a list, but names is a tuple. Okay, and then so even though names is a tuple, I can put it in the tuple as an extension to berries. Okay, berries extend with tuple with the tuple names. You see what it is. Okay, and remember, it is just adding it to berries. Okay, so and I call the berries. It brings out all the berry items and then subsequently appends these names here. Okay, and it is becoming a full list. So it's getting converted as a list and then adding it to the berries list. So that's what I have done here. Can I convert a list to a tuple? Of course you can do. For that you have a function called tuple. Like list converts a tuple, tuple converts a list. Okay, so that's what I have done here. So I take the berries, which is a list. I use it in the function called tuple, and then it becomes berries tuple, and you can see that the container difference. Okay, here. Okay, berries tuple, because berries already has all these names, and the berry names and the person names. The whole thing is becoming a tuple here, and then I already have a berries tuple. Now can I convert it back to list? Yeah, you use the function list. So berries tuple, and then I call it berries list. Okay, so I call it, and now it has become a list. Okay, so you can move between tuple and list, and oftentimes that's also interesting, useful function. Thank you very much, everybody. See you next time tomorrow. Bye bye.